Hello everyone, welcome back to our chemistry class. So we are still in chapter 3 periodic table. So this is a video of periodicity part G. So in this video we will be talking about successive ionization energy and how to determine the valence electron based on the successive ionization energy. So we already learned in the previous video about ionization energy. Okay, so when we look at the example of ionization energy, positive 736 kilojoule per mole is the first ionization energy required, and positive 1450 kilojoule per mole is the second ionization energy required. Okay, so that is the successive ionization energy. In general, the successive ionization energy is always increasing, because what happens when the electron is being pulled away from an increasingly more positive ion, it requires more work. As you can see there, when electron is being pulled away from the magnesium gaseous atom, the ionization energy is positive 736. Okay, when the second electron is being pulled away from the magnesium gaseous ion, the second ionization energy becomes 1450 kilojoule per mole, and we can see that it is successive, meaning to say nilai ionization energy itu bertambah tinggi. But when there is a large increase ataupun dia ada drastic changes in successive ionization energy, meaning to say the electron is being removed from the inner shell of the atom. So what is that means? So let's take a look at example 1. We are looking at element lithium. So the electronic configuration for lithium is 1s2 and 2s1. Therefore, the valence electron shell is 2s1 and 1s2 is the inner shell. So when we draw the orbital diagram for lithium, it is as shown in the video. As I told you before, 2s is the valence electron shell, while 1s2 is the inner shell. Electron will be removed from the outermost shell first. So meaning to say, the electron in the 2s orbital will be removed first. Then that removal will give the first ionization energy for lithium. And then the second electron will be removed from the 1s orbital. Then the removal of that electron will become the second ionization energy. When we look at the table, okay, we can see that the first ionization energy is 520, while the second ionization energy is 7297. Okay, when we compare the ionization energy, we can see that there is a drastic increase in ionization energy between first ionization energy and the second ionization energy. Why is that happening? Okay, so when this is happening, we can conclude that the second electron, the second electron is located in the inner shell. So meaning to say, the first electron is the valence electron. Okay, the drastic increase of ionization energy is happening because the second electron is being removed from the inner shell, which is the 1s orbital. Next, let's take a look at the second element, beryllium. So the electronic configuration is 1s2 to s2. So mari kita draw dia punya orbital diagram, 1s2 dan juga 2s2. So Lepas kita draw, kita buat dia punya border, and then we know that 2s2 is the valence electron shell, while 1s2 is the inner shell. Remember, electron is being removed from the outermost shell first, so meaning to say the removal of one electron is happening in the 2s orbital. That will become the first ionization energy with 900 kilojoule per mole. Next, the removal of the second electron also in the 2s orbital, and that will become the second ionization energy with 1760 kilojoule per mole. And then the third electron is being removed from the inner shell electron, thus that will become the third ionization energy with 14850 kilojoule per mole. So as you can see there is a drastic increase in the second and also in the third ionization energy. So if we are given a data like that, okay, we can conclude that the removal of the third electron is happening from the inner shell. Thus, the first and the second electron is the valence electron of the element. So for beryllium, the sudden increase is between the second and the third ionization energy, because the third electron is being removed from the inner shell, which is 1s orbital. Next, let us take a look at boron. So the electronic configuration is 1s2, 2s2 and 2p1. So first, we draw the orbital diagram for boron. And when we draw the border between the principal quantum number, so the valence electron shell is 2s and 2p, while 1s is the inner shell. The electron in 2p will become the first electron to be removed, therefore it will give the first ionization energy, which is at 100. The second electron that will be removed is from the 2s orbital. Okay, then it will become the second ionization energy with the value of 2430, and the third electron that will remove also comes from the 2s orbital. Okay, so it will give the third ionization energy, which is 3659, and then the fourth electron to be removed is from the inner shell 1s orbital with the ionization energy 25020. As you look at the first, the second and the third ionization energy, we can see that the value of the ionization energy is increasing. So as you can see there will be drastic increase between the third ionization energy and also the fourth ionization energy. So we can conclude that the fourth electron is being removed from the inner shell. Therefore, the first, the second and the third electron is located at the valence electron shell. Therefore, for boron, the sudden increase or the drastic increase is between the third and the fourth ionization energy, because the fourth electron is being removed from the inner shell. So as a conclusion, if we are given a data of successive ionization energy, we can deduce three things, which is the number of valence electron, the group of the element, and also the electronic configuration. And please take note that the ionization energy that you determine is only for the S block and P block element. In other words, we can only use it for group 1, group 2 and group 13 to group 18 only. Okay, now let's take a look at example 2. So as you can see there, the first, the second and also the third, the fourth, the fifth, that is the successive ionization energy for an element. And as we look closely, okay, there is a drastic increase in ionization energy between the third and the fourth ionization energy. So, meaning to say, the third electron is the last valence electron to be removed, and the fourth electron is located in the inner shell. Therefore, this element have 3 valence electrons. This element is located at group 13 with valence electron configuration NS2 and P1. Therefore, this element is belong to the P block. So, ini adalah template yang kamu boleh gunakan untuk explain successive ionization energy. So, the drastic change happen between the third ionization energy and the fourth ionization energy. Thus, the fourth electron is removed from the inner shell. 3 valence electrons are present. So, the valence electron configuration is NS2 and P1, and this element is in group 13. So, for example 3, I want you to do it by yourself now. So, please pause your video and I'll give you the answer in a minute. So, this is the answer for example 3. So, good job of getting it right, meaning to say you really understand what this video really talking about. So, example 4, you are given 2 atoms W and X, and also their respectively ionization energy, the first, the second, the third, and also the fourth. The first question is you were asked to explain why the first ionization energy of W is higher than X, and then you need to predict the number of valence electron and write the electronic configuration for W and X, and you were asked to give the set of quantum numbers NLMS for the outermost electrons of W and X. So, to answer this question, we need to look at the data of successive ionization energy given in the question. So, we need to look at the drastic increase and also the number of valence electron first. So, for atom W, as we can see there, the drastic increase is happen between the second and also the third ionization energy. More energy is needed to remove the third electron, so meaning to say the third electron is located at the inner shell. Therefore, the first and the second electron is the valence electron. So, for atom W, it has 2 valence electrons. The drastic increase in ionization energy happens between the second and the third ionization energy, and therefore we can conclude the electronic configuration because you are given the period. So the electronic configuration for W is 1s2 2s2. Next, for X, so as we can see from the ionization energy data, we can see that there is a drastic increase between the third and the fourth ionization energy. So meaning to say the fourth electron is removed from the inner shell, and electron 1, 2, and 3 is the valence electron. Therefore, for atom X, the number of valence electron is 3, and the drastic increase is happening between the third and the fourth ionization energy because atom X is located in period 2. Then the electronic configuration for atom X is 1s2 2s2 2p1. Okay, now we already have our deduction regarding to the successive ionization energy data, so we can start answering question A first. So question A, you were asked to explain why the first ionization energy of W is higher than X? Okay, to answer this question, we need to take a look at the electronic configuration of W and X. So for W, the valence electron shell is 2s2, while for X, the valence electron shell is 2s2, 2p1. So when we look at the orbital diagram for the valence electron shell for W and X, we can see that the first electron to be removed in W is located in 2s orbital, in which it is a fully filled orbital. But for X, the first electron to be removed is located in partially filled 2p orbital of X. So ini adalah jawapan yang full untuk soalan A. So bila kita tengok tadi, okay, orbital diagram untuk W, kita nampak bahawa first electron to be removed itu is located at the 2s, yang mana 2s itu dia fully filled orbital. Okay, so maksudnya untuk remove one electron daripada fully filled orbital yang sudah stabil itu, ianya akan memerlukan lebih banyak tenaga. Manakala untuk elektron yang pertama di dalam 2p orbital itu, dia partially filled orbital bah. Jadi less amount of energy is needed to remove that electron. And moreover, bila kita remove itu elektron, yang tinggal hanyalah 2s kan. Jadi X akan jadi lebih stabil. Therefore, the first ionization energy of W is higher than X. Next, for question B, you were asked to predict the number of valence electron for W and X. Hence, write the electronic configuration for W and X. So, bila dia minta predict, so meaning to say kamu kena bagi explanation juga. Kenapa kamu predict macam begitu? So, this is the full explanation about how to answer the question B. So, W has the valence electron because there is a drastic increase between the second and the third ionization energy. Okay, more energy is required to remove the third electron. Thus, the third electron is removed from the inner shell. Itu untuk explanation bagi W. Next, for X, X has 3 valence electron because there is a drastic increase between the third and the fourth ionization energy. Meaning to say, more energy is required to remove the fourth electron. Thus, the fourth electron is removed from the inner shell. So, the question also asks you to write the electronic configuration. So, the electronic configuration is for W and X is as follows: W 1s2 to s2, X 1s2 to s2 to p1. Next, question C, you were asked to give the set of 4 quantum numbers and LMS for the outermost electron of W and X. So, ini adalah outermost electron bagi W dan juga X. So, kalau kita tengok, W ada 2 outermost electron. Jadi, for W, the N is equals to 2, the L is equals to 0 and 1, tapi sebab dia s orbital, jadi L dia sama dengan 0. Bila L sama dengan 0, M sama dengan 0 dan S akan jadi positive or negative half. So the first quantum number is 200 positive half and the second quantum number is 200 negative half. So dia akan ada 2 set of quantum number di sini sebab W pada orbital 2s dia ada 2 elektron. Next, for X, okay, we only have 1 outermost electron which is located in the 2p orbital. So meaning to say, for X, when N is equals to 2, dl is equals to 1 sebab dia p orbital, maka M kita boleh jadi negatif 1, kosong dan positif 1, dan S kita sama dengan positif and negative half. Okay. So, untuk X ini, dia ada 6 pilihan jawapan yang kamu boleh tulis ya. So, yang pertama 2, 1, negative 1, positive half, or 2, 1, negative 1, negative half, or 2, 1, 0, positive half, or 2, 1, 0, negative half, or 2, 1, positive 1, positive half, or 2, 1, positive 1, negative half. So itu sahaja untuk video kali ini. So kita akan sambung video yang seterusnya, yaitu the last video for these topics. So I'll see you in a while guys. Take care and bye bye.